For centuries, we have treated science as an expedition to conquer a mind-independent universe from the outside. We assume reality is a vast, static warehouse filled with hidden objects, waiting patiently for us to extract their secrets and catalog them. This creates a hard boundary between the observer and the observed. It trains us to stand apart from the natural world, adopting a posture of control rather than connection. But every measurement we take and every theory we draft is completely bound by our finite cognitive constraints and the specific instruments we use. The observer's constraints are the very conditions that make a coherent universe appear to us at all. Beneath our everyday experience lies an ultimate generative background, a web containing all possible computational rules and their entangled consequences, known as the Ruliad. Coined by Stephen Wolfram alongside his work on computational plenitude, it represents an infinite, restless, mathematical totality. Our human brains do not have the memory or the processing power to track that totality. We act as a reducing valve, carving out a tiny, manageable slice of reality that our minds can actually process. Donald Hoffman describes this slice as a survival-tuned user interface, filtering raw data into simplified shapes. These physical objects are not literal snapshots of absolute physics. They function like desktop icons, evolving to keep our actions tractable. What we experience as solid objects moving through space and time is a highly useful dashboard. It is shaped by evolutionary costs and biological goals, not the literal furniture of the universe. Scientific laws are slice invariants, robust regularities that remain stable only within the limits of our specific biological and cognitive interface. Using topos theory, we model two distinct slices with different geometric rules, one straight, one curved. Truth depends entirely on local context. What's true on the left may be indeterminate on the right. The goal is accurate translation between them. This mathematical reality mirrors the ancient Buddhist concept of sunyata, or emptiness. It is the realization that no object possesses a self-standing essence independent of its relationships. Because reality appears strictly through these context-dependent relationships, insisting on a single global truth that applies to every corner of existence is mathematically impossible. If our world is an interface, claiming absolute objective dominance over nature is a logical error. It assumes we are seeing the true machinery rather than our own reflection. Dominating the physical universe is like trying to rewrite a hard drive by smashing the folder icons on the monitor. Confusing our evolutionary icons for the source code of reality leads to destructive brute force interactions. We break the screen instead of understanding the software. Recognizing the world as a fragile, shared interface makes epistemic arrogance untenable. If truth is local and relational, our posture must shift toward humility and corrigibility. This is participatory realism. If reality appears through relationship, knowledge is inseparable from responsibility. Progress is no longer about domination, but about building translation maps between different observers, learning to reconcile human experience with quantum systems or future artificial intelligence. This makes the ethical dimension of science unavoidable. When we realize we are participating in the creation of our world, a theory's value is judged by whether it helps us protect and sustain that shared interface. Science can finally shed its legacy of conquering an external universe. Instead, it becomes the profound, ongoing craft of learning to resonate within it.